Hello friends and my dear students, I welcome you all to my channel. This is part 5 video on the chapter of compound interest where I will discuss the general formula for this is case 2 for a formula where the compound interest is calculated annually but the rates are different for different years. If you have not watched the previous 4 parts of the video on the compound interest, then I strongly suggest and request that you please watch them also to maintain the continuity of your study on the chapter of compound interest. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, or if you are visiting my channel for the first time, or if you are watching this video for the first time and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel and do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my very rough and incomplete notes prepared on the right hand side. So let's discuss how do we calculate the compound interest when the interests are calculated or compounded annually. That is, we calculate the interest at the end of every 1 year, but the rates are different for each year. So we are calculating amount on rupees P, where P is the original principal at rates X% per annum and Y% per annum on the first and second year respectively, compounded annually for 2 years. So the formula is amount A is equal to P multiplied by 1 plus X by 100 multiplied by 1 plus Y by 100, where X is the rate of interest per annum in the first year and Y is the rate of interest per annum in the second year. And this is the formula of amount that will result from the original principal P in 2 years with the rate X% in the first year and the rate Y% second year. Now, to understand this formula, it is very simple. It is based on the very fundamental concepts of calculating interest at the end of every unit of time. Now, since in this case the interest is being compounded annually, so the unit of time is 12 years. 12 months. So so we start from the principal. What is happening? Let me fix my canvas. Okay, so how this formula is coming now? So we start from the original principal P, and since the interest is being compounded annually, so we have after 1 year at X% per annum. After 1 year, the interest calculated after 1 year will be at the rate X% per annum on the principal P. So we know, as per our discussion in all the previous videos, we know using this diagram we understand how the compound interests are being calculated. So the I1, the interest at the end of first year, I1 will be the principal, the current principal, which is the original principal P. Now since it is the interests are being compounded annually, we will have R dash is equal to R. So in this case R is X. So we have P X by 100. Px by 100 will be the interest at the end of first year, where the rate of percent is X% per annum. So the amount A1 will be P plus I1, which is equal to P plus px by 100. This is equal to, if you take p common, p multiplied by 1 plus x by 100. So this is the amount, that is A1, at the end of first year. Amount is A1, which is p into 1 plus x by 100. Now, after another 1 year, after 1 year, now the interest will be at y% per annum, y% per annum. And what will be the interest and amount? The current principal, as we know, the current principal is the amount that was formed at the end of the previous year, which is A1, which is equal to p into 1 plus x by 100. So at the end of second year, we are having the interest I2 is equal to P1. This time the rate of interest is y, so y by 100. This is equal to P1 is P multiplied by 1 plus x by 100. So A2 amount at the end of the second year will be equal to P1 plus I2. This is equal to, what is P1? P1 is P1 was P1 is at the end of P1 is the current principal to be applied while calculating the compound interest at the end of second year, and the current principal will be equal to the amount that was resulted or that was formed at the end of previous year, which is equal to A1. So basically P1 is equal to A1. So this is equal to, what is P1? P1 is equal to A1, which means P into 1 plus x by 100. And what is I2? I2 is P into 1 plus now I2 is equal to P1 multiplied by y by 100, which is equal to P1 is equal to P1 is equal to P into 1 plus x by 100, and there was a y by 100. So there is a y by 100 I2. Okay. So now we have A2 is equal to P1 plus I2, and P1 is equal to P into 1 plus x by 100, plus I2 is equal to P into 1 plus x by 100 multiplied by y by 100. This is equal to, if you take P into 1 plus x by 100 common, we will have P into 1 plus x by 100 multiplied by 1 plus y by 100. So we got the result as per the formula. The final amount after the end of second year is P into 1 plus x by 100 multiplied by 1 plus y by 100. So this is the formula. The amount A is equal to P multiplied by 1 plus x by 100 multiplied by 1 plus y by 100. This is the formula for the amount on the principal P, where for 2 years, where the rate of interest is x% per annum for the first year, and the rate is y% per annum for the second year. Okay. Now this can be extended to any number of years. In this case, this formula is for 2 years, where the first year is having one particular rate of interest, and the second year is having another rate of interest, and the interest is being compounded annually. This can be extended to any number of years, where the rate of interests are different for every year. So let's see for 3 years. what will be the formula for calculating amount on a principal P at rates X% per annum, Y% per annum, and Z% per annum on the first, second, and third year respectively, and the interest is being compounded annually for 3 years. So, what will be the amount after 3 years on the principal P, where the rates are X% per annum for the first year, Y% per annum for the second year, and Z% per annum on the third year. So, the formula is A is equal to P multiplied by 1 plus X by 100 multiplied by 1 plus Y by 100 multiplied by 1 plus Z by 100. Now, how this formula is coming is very similar to the formula, the derivation of the formula as we explained for rates of two rates for two different rates for 2 years. So let's try to anyway understand how this formula is coming. So first we so this is for 3 years. This is the amount for 3 years where the rates are where the rates for the first, second, and third year are X, Y, and Z%. So we start from P. So after 1 year, or after, let's say, first year at X% per annum, we will have, I will not write the calculation in details. I will straight away write the result. So we know that after 1 year on the principal P, after 1 year and at the rate X% per annum, the amount A1 will be equal to P multiplied by 1 plus X by 100, and definitely the P1 will be equal to A1, that is the principal to be considered for calculating the interest in the next year will be equal to the current amount. Okay, and after second year at the rate is different at Y% per annum, what will be the amount? The amount will be, as we know, the current principal which is P1, which is equal to A1, which is equal to P into 1 plus X by 100. This is the current principal, and multiplied by 1 plus the current rate, that is Y by 100. So this is the amount at the end of second year, and obviously P2 will be equal to A2, that is P2 is the principal to be considered for the next calculation of interest for the next year. So we have completed 2 years, and at the end of 2 years the amount is P into 1 plus X by 100 multiplied by 1 plus Y by 100. Similarly, for another, after the third year, the rate is different. So at Z% per annum, we will have the interest we will have the amount A2, A3 will be equal to the current principal, which is P2, and which is equal to A2, which is P multiplied by 1 plus X by 100 multiplied by 1 plus Y by 100. So this is the current principal, which is basically the amount resulted at the end of previous year. Now we have to multiply with the factor 1 plus Z by 100, as the current rate is Z% per annum. So this is the final amount, and as you can see, the this is as per the given formula. This is the general formula for uh, computing the amount based on the principal P for 3 years, where the interest is being compounded annually and the rates are different for the 3 different years, where X% per annum is the rate for the first year and Y% per annum is the rate for second year and Z% per annum is the rate for third year. Okay. Now, these first two examples, first two formulas can be further extended to a more general form of computing the amount where the interest is being compounded annually, but this time let's say the the rates are different for more than 1 year. So let's say we have to compute the amount on the principal P for m plus where the interest is being compounded annually and the total time period is m plus n years and the rates are different, such so that the rate is X% per annum for the first m years and the rate is Y% per annum for the next n years. So the total time period is therefore m plus n years, where the rate is X% for the first m years and the rate is Y% for the next or the last n years. The formula is A equals to P multiplied by 1 plus X by 100 to the power m and 1 plus Y by 100 to the power n. Now, I am quite sure you are able to understand why this formula is like this. You know, it is quite straightforward. So we start from P, and let's say, so what will be the amount after m years, where after m years where the rate is X% per annum. So based on the principal P, what will be the amount where the interest is being compounded annually after m years, where the rate is X% per annum. So this is definitely the formula. The formula for amount will be A1 is equal to P multiplied by 1 plus X by 100 to the power m. Because you know that the amount on a principal P at the rate of X% per annum when the interest is being compounded annually for m years is P multiplied by 1 plus X by 100 to the power m. So after first m years, the amount is A1 equals to this. So definitely the principal to be the principal for calculating the total amount for the next n years will be P1, which is equal to A1. Now we will compute what will be the amount after n years where the interest is being compounded annually at the rate Y% per annum. This will be A2 will be equal to the current principal, that is the principal at which it is starting, which is P1. So P1 multiplied by 1 plus Y by 100 to the power n. This is the amount that will result on the principal P1 after n years, where the interest is being compounded annually at the rate of Y% per annum. Okay. Now P1 we know is A1, and A1 is P into 1 plus X by 100 to the power m, and we have 1 plus y by 100 to the power n. So this is how we get the formula that the total amount on principal P uh, after m plus n years, where the rate is x% per annum for the first m years and the rate is y% per annum for the next n years, is equal to, amount is equal to P multiplied by 1 plus x by 100 to the power m and multiplied by 1 plus y by 100 to the power n. Okay. So these are basically the general formulas for calculating the compound interest when the interest is being compounded annually and the rates are different for every year. For each year the rate is different. Now it is possible that the rate is there is a specific rate for some consecutive number of years, like in the case 3, we are computing the amount for m plus n years, where for the first m years the rate is same, that is x% per annum, and for the last n years the rate is same, that is y% per annum. Now one thing to note regarding this formula of computing the amount for a certain period of time, where the interest is being compounded annually and the rates are different for different years. So one thing to note is that if the order of the rates are changed, like in the case 1, in this case, if we are asked to find the amount on P, but the rates are y% per annum for the first year and x% per annum for the second year, then the result will be same. The result will be same because we know that in that case, if the order of the rates are changed for the case 1, where we are trying to find the amount on a principal P for 2 years, where the interest is being compounded annually and the rate is x% per annum for the first year and y% per annum for the second year. If the x% and y% the order is changed, then the formula will be the same, because we know that then the formula will be A is equal to P multiplied by 1 plus, for the first year the amount at the end of first year will be P into 1 plus y by 100, and this is P into 1 plus y by 100 will be the principal to be considered for calculating the interest at the end of second year. And at the end of second year the rate is x% per annum, so the amount will be, this is the current principal, and we have to multiply 1 plus x by 100. Now clearly these two are same. So if the order of the rates are changed for case 1, the formula remains the same. Similarly is the case for second case, when we are computing the compound interest for 3 years, where the rates are different, that is x% per annum for the first year, y% per annum for the second year, and z% per annum for the third year. If the order of these rates are changed, the formula will remain the same. It will be same, even though the expression of the formula may look different, but the value is same. The value is same. Also for the case 3, that is when we are calculating the amount for m plus n years, let's say in this case the rates are, or the order of the rates are changed, that is the rate is y% per annum for the first m years and x% per annum for Now, I don't think for the case 3, if the order is changed, that is if the rates are changed. Uh, so let's say if the order is changed in this case 3, that is the rate is y% per annum for the first m years and the rate is x% per annum for the last n years, then what will be the amount? So if rates are if rates are y% per annum for first year and x% per annum for second year. For this case, if we have to find the amount for 2 years where the interest is being compounded annually and the rates are y% per annum for the first year, and no, sorry, if the rates are y% per annum for not first year, sorry, not first year, but uh, if the rates are y%, if the rates are y% per annum for first m years and x% per annum for next n years, then the amount will be as per the formula P multiplied by first for the first m years. At the end of first m years, the amount will be P multiplied by y divided by 100 to the power m. So this is the amount after the first m years. Now this will be the principal, that is P multiplied by P into 1 plus y by 100 whole to the power m. This will be the principal to be considered to calculate the compound interest for the last n years at x% per annum. And so the amount at the end of m plus n years will be, so this is the principal, and we will multiply with the factor 1 plus x by 100 to the power n. Now this and this quite obviously are not same. So if for the case 3, if you change the order of the rates, that is so the formula for calculating the amount for m plus n years where the interest is being compounded annually and the rates are x% per annum for the first m years and the rate is y% per annum for the last n years, whatever the formula is, that will not be the same if you change the if you interchange the x% and y%. The formula will change. The formula will not be the same, because as you can see, for this we are having 1 plus x by 100 to the power m, but for this we are having 1 plus x by 100 to the power n. These two are different. Whereas in the first two cases, if we change the order of the rates, the result is the same. In this case, for the case 2, if we change the order, let's say the rates were y% for the first year and then z% for the second year and x% for the third year, then the amount would be P multiplied by, the amount at the end of first year will be P multiplied by y by 100, and the amount at the end of second year will be 1 plus z by 100, and finally the amount at the end of third year will be this. As you can see, this expression and this expression, they are same. So it does not matter if you change the order of the rates, that is, whatever the rates are for the first year, second year and third year, if you interchange them, the final value of the amount will remain the same. Similarly is the scenario for the case 1, that is, for 2 years, if the rates are x% and y% respectively, that is x% per annum for the first year and y% per annum in the second year, if you interchange the x% and y%, the final amount in 2 years will be the same, because as you can see, this expression is same as this expression. So this is all about the formula for calculating the amount for certain period of time, for certain period of time in for certain years, where the interest is being compounded annually and the rate of interest per annum are different for each individual years. So we have three cases, where the third case is a more general form. Now the third case can also be extended. So I have in the third case is, we are having x% per annum for the first n years and then y% per annum for the next n years. Now this can be extended for any number of rates of percentage for any consecutive years. As an example, if you have let's say the rates are let's say the rates are x% per annum for first m years, y% per annum for next n years, and z% per annum for next p years, then in m plus n m plus n plus p years, the total amount will be, that is the amount after m plus n plus p years will be, of course the principal is p, the initial principal is p, it will be p multiplied by 1 plus x by 100 to the power m 1 plus y by 100 to the power n multiplied by 1 plus z by 100 to the power p. This will be the formula. This is an extended formula for the case 3. This can be, now you can generalize this for any number of rates of interest that are applied for any consecutive years. I hope I was able to explain properly the formulas for calculating the amount for a certain period of time, that is years, where the interest is being compounded annually and the rates are different for different years. So I will not solve any problem. I just wanted to discuss about the formula. Probably while solving the exercise problems of the exercise of the subsequent exercise, it will be clear how we will apply these concepts to solve the problem. In the next video, I will discuss about the applications of compound interest in real life scenarios, like how like for example population, the rate of decrease or rate of increase of population is based on compound interest. Also the rate of the bacteria, and the birth and death of rate of birth and death of a bacteria is also based on compound interest. All those scenarios we will explain uh, with some uh, with some illustrative examples. So that is all for this video. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So thanks for watching, and until the next video, take care and bye.